All right, so near that tangent line, that tangent line a lot of times is called L, not ft, L of x. It doesn't have to be. Sometimes it's called y, but I like to call it L. All right, and so what we can do is just know that for values, x values, near x equals a, L of x is approximately f of x. And the closer the better. The closer the better, the approximation.
Is it x equals a or x equals
It's a, thank you. Okay, and this is something I wanted you guys to figure out. And I heard some of you did figure it out, but it's okay if you didn't, because I'm going to tell you now. So if a function is concave up, so like the second half of this graph, when you draw a tangent line, the best place to draw is at a minimum for a concave up. Is that going to be an over? If we use the tangent line, is that going to be an over or under estimate? Under, because the tangent line is falling below. All right, and then I already drew a little tangent line for concave down, and you can tell that that is going to be an overestimate. Because the tangent line is above the curve. And so we have some examples of things that are pretty commonly used for tangent line approximation just because of what you're given. Obviously, the best way to figure out the value of a function is to plug the value into the function. But there's a whole lot of times when you don't have the function, so you have to use another method. So on number 1, we have f of x. We do know 1 point on the function that f of 2 is -6. And we know the derivative. We know we can find the slope by using this derivative. We're going to write an equation of the line tangent to x equals 2, and then we're going to use it to approximate f of 1.8. So what are the two things I need for a tangent line?
Pots.
Yes. And we know the pot is the point to -6. And we can find the side by taking our derivative and plugging in the pot. Now this is one of the cases where you have to plug in the x and the y, and that's fine. It's not a problem. So it looks like we're going to get 18 over 36, or as much as I love fractions, these actually work out better when we do decimals. So what is that going to be as a decimal? 0.5, good. Now I will pretty much always choose fractions except on these problems. All right, so we're going to write our tangent line. I am going to call it L. You do not have to, but that's just what I like to do. All right, and I'm hoping you guys remember. It's been a little while since we've done this, but we reviewed it on the other side. All right, so that is the first part of the question. So if this was an FRQ, you would get a point for that. And then what we're going to need to do is use it to approximate 1.8. So we're going to plug in 1.8. All right. All right, so then we're going to get -0.02. Now that's a little more challenging than just multiplying by 0.1 or 0.01, but it's still totally doable. You're just going to have to reach back into your brain. I don't have a lot of space, but I'm going to multiply those up here. All right, so we are going to multiply. Well, I know I'm going to get a negative, so we'll take care of that down here. 5 times 2 is going to be 10. So obviously the answer is not 10. So how do you know where the decimal place goes?
Because there's 2 decimals.
Exactly, you count. So here's 1, 2. So we have to do 1, 2. I know it's been a very long time since you guys did
I
that.
remember learning that.
In like
elementary
6th grade,
school.
elementary school?
Yeah.
All right, so we have an approximation. Now, I've never graded the AP test officially. So what I think they want to see is you're using L to approximate F. So at some point, you would want to write that F of 1.8 is approximately negative 6.1. You're right. Freezing?
I'm like frigid.
Any questions on that? So it's stuff we've done before, just with a little extra at the end. Okay, well we got to do some trig stuff. So on A, we're going to use the tangent line of G at pi over 2 to approximate 1.5. So pi over 2 is close to 1.5. So we're going to do our plot and our slot. So the plot, we're going to put in pi over 2 into the original. I love asking you guys these questions. You know this better than any calculus students I've ever had, and I don't know why. Maybe you're just geniuses. But what is the sign of pi over 2?
1.
So 3 times 1 is 3, plus 1 is 4.
I don't know why, but something about it just is tattooed in my brain.
I love it. All right, we're going to do g prime of x. So you guys do that on your own, please.
Do we have to do product rule?
No. Because that 3 just gets multiplied by whatever the derivative of sine is. If it had an x, you would need to. All right, what about the cosine of pi over 2? Yeah. So if the slope is 0, what does that mean? It's a horizontal line. Very good. So when we write our tangent line approximation, it's going to be a horizontal line. And it's a horizontal line through the point pi over 2, 4. So it's just going to be equal to 4. Does that make sense? Okay. So if we're going to approximate g of 1.5 using that tangent line, what should it be? Yeah. Very good. Okay, and then this one tells you to use your calculator to find out what that is. Do you guys want me to just tell you? You end up getting 3.992. So that's a really good approximation. How much was it off by?
0.08.
Nice. And it was a over approximation. So does that mean that this is concave up or concave down at that point? That was just a bonus question. So we got an overestimate from our... All right. So example 3, we are going to sketch a graph of a function where the tangent line approximation at x equals 1 will be an underestimate for the actual function values near 1. So what does this graph need to look like? Yes. It just needs to be concave up. 1, it could do all kinds of other stuff, other places, but I just drew a really easy one that was concave up. Because the tangent line there is going to fall below. I didn't draw a great tangent line, but... right, and then one more question. So we are going to let h be a differentiable function, and so we are given the pot and the side. That's great. And so if the tangent line to h of x at 4 is used to approximate the zeros of h, then those zeros are... So let's just start off and write our tangent line. So we're using this in a totally different way. We want to use this.
Is it usually the pod minus or plus the sine?
Did I do something wrong?
No, I just
I
can't
think it's
remember.
not like plus, it's negative too.
It's plus. It's plus, but it's negative here because there's a negative slope. That's a good question.
I just can't remember.
This is what it is if you want to jot it down.
I'm gonna write that down because I'll also know this.
Okay, so we don't want to use it to make an approximation about like 3.9 or 4.1. We want to use it to find a zero. So what do you guys think we need to do? Yes. I'm going to go ahead and distribute that negative 2 if that's all right with y'all. All right, so 11.5 is going to be 5.5.
Is it negative 11
I don't think so. I moved my 2x over.
Oh, you did? Okay. I did not.
It's okay. All right, what other questions do you guys have? That's not too terrible. All right.
I can already tell this one of those lessons I immediately